This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hi, this is Priyanka Raghavan for Software Engineering Radio. In this episode, we will deep dive into Consul, the service mesh from Hashicorp. And my guest today is Luke Kysow, Consul engineer at Hashicorp. Luke is also the maintainer and co-creator of Atlantis, an open source tool for Terraform collaboration. Luke has given many talks in different software engineering conferences, so really excited to have you on the show. Welcome to the show, Luke.
Thank you so much for having me.
Is there anything else you would like listeners to know about you before we jump into Consul?
No, I think you mostly covered it. I'm engineer at Hashicorp. I work on Consul. And prior to that, I did a lot of DevOps and just regular development at a couple other companies.
Perfect. As you know, we've done a couple of episodes on microservices as well as service discovery. We did an episode 2 years back on Istio, the service mesh from Google. And 4 years back, we talked about service discovery, and obviously a lot has changed it's actually 5 years, right? It's 2021. So we'll try to cover what's changed since then.
Yeah.
So the first thing I need to ask before we actually jump into Consul is, could you recap for our listeners, what is a service mesh in your own words?
So when we think about a service mesh, I think the most common kind of way that this looks is you have every single service that you are running in your architecture has a proxy that runs in front of it. And that proxy captures the traffic that leaves your service and also captures the traffic that's entering your service. Now that you have this proxy in front of every application, you're now able to control the traffic that goes into and out of that application. And that's kind of what a service mesh is the ability now is like this mesh of proxies. And now you can control where that traffic goes, whether or not it's allowed into the application. You can control all that through a control plane. So I think that's like when we think about service mesh, that's kind of what the basic manifestation of it is.
So in the 2016 episode, which was episode 264, the guest James Phillip from Consul as well, he talked about the architecture being a Consul agent running on different nodes. And then the service discovery happens through the gossip protocol. That's a gist of what he said. Mm-hmm. What's new and what's changed since then?
Yeah. So we have this division now between the idea of service discovery, which is kind of the older concept, and this new world of service mesh. And it's a little bit complicated, like what exactly is the difference between these? Because in the end, it's just one service calling another service. We'll just talk a little bit about service discovery. With service discovery, what we have is we have a list of all of our applications and all of their IP addresses and their ports. We're able to know where this application is. And then from within our application, so for example, say we have a web service and it's trying to call the database. The web service can look up within the service discovery mechanism, okay, where is this database running? And then it can direct this traffic over there. So this lookup can be done through DNS, was traditionally how it would work. So you would use like example company.database, and then the service discovery mechanism would tell you, oh, the IP address for that is 10.10.10.10 and then I can just talk to that on port, whatever port. So what's evolved since then is now the application, instead of kind of participating in that service discovery where it needs a way to find out itself what the IP address is for the database, instead the application talks through a proxy. And so now that proxy is the thing that's doing the lookup for where the database is. You look at that and you say, okay, well, what's the point of the proxy then? My service could have just done a DNS lookup. But now that we have this proxy there, the proxy can do so much more than just do a DNS lookup, right? It can control where that traffic goes. It can retry that traffic. It can notice that that application is down and use like a circuit breaker pattern where it doesn't send it traffic, or maybe it can fail over to another data center where maybe the database is actually up and running. That's really the evolution there, is that now we're kind of handing off this where does my request go step to the proxy. And that gives us so much more power. And the reason we didn't do that before was it was extra complexity that we didn't need. But now that we have kind of this world of microservices and dynamic services, there is a lot more complexity in how our network works that we do find ourselves needing to program and add some smarts in there. In addition, with the rise of platforms such as Kubernetes, it's a lot easier to deploy that proxy now alongside all of our applications. You could imagine back when James Phillips was on the show in 2016 and we didn't have Kubernetes.
Mm-hmm.
If I were to tell you, okay, all you need to do now is deploy a proxy on every single VM you're running by every single application and configure it with a certificate and rotate that certificate. That was a very large job.
Mm.
But now with some platforms like Kubernetes, where, and again, you'll see this pattern of kind of programmability, where now we can kind of program what the application actually runs and what runs alongside it. So concretely, I'm talking about how we now have this concept of pods, and we can actually add containers, Docker images, to run alongside those pods. Now it's so much easier to add that proxy to all of our applications. And that makes this pattern a lot more viable.
There is a lot of stuff that you've told us in this introduction, but let's sort of break it down. If I were to ask you, what are the main components of the service mesh? So I think one you alluded to was, of course, service discovery.
Right.
And also, I guess, how healthy your resources are.
Right.
And then what are the other components?
Yeah. So the key pieces of information that we needed to know are, where are the services? So that's the service discovery mechanism. So where is the database and what is its IP address? How can I route there? The second one is like you mentioned as well, like, is the database healthy? Can I route to that? And that's really all that we need. When we do start talking about, which we can talk about later, the idea of like multiple clusters, then we do need some extra information. The other piece of information that we need, and it's very kind of important to the service mesh, is this service, this web service, allowed to talk to this database? So kind of the authorization there is web allowed to talk to DB. So those are kind of the information we need. And then the components, like the concrete components involved, are the proxies themselves, and then what we call the control plane. So the application that's programming those proxies and telling it what each proxy should be doing.
So for the last 2 months at work, I've been struggling with bringing up open source API gateway. So I just have to ask you this before we jump into Consul. Do I need to also have an API gateway when I have a service mesh?
Yeah, that's a super great question. Yes, the answer is that the problems that an API gateway solves aren't being solved at the same time by a service mesh. Although I will say that the two technology areas are becoming increasingly overlapping. But when we talk about what we think about with a service mesh, traditionally it's been service to service traffic. So it's the web service that's talking to the database. It's the billing service that's talking to the payment service, let's say. And so you're kind of talking about this service to service traffic, whereas an API gateway is obviously external consumers trying to talk into your API. And so the functionality is similar, but a little bit separate. So with the API gateway, you might have a bunch of logic around developer tokens. Who is this person coming in? Are they allowed to access this API? Rate limiting, et cetera, et cetera. So kind of more, you might have like an admin panel that lets you see which developer tokens have been called in. So there is a little bit more functionality kind of as a result of having to manage the fact that these are external clients. Whereas for the service mesh, typically these are internal clients. And so we don't necessarily have a bunch of tokens where we have to rate limit based on that. Instead, we might do kind of like a service level rate limiting. The functionality is overlapping. However, they are kind of separate concerns at this time.
Okay, that makes sense. Let's jump into Consul now. You did touch upon service discovery. How do services in Consul discover other services? The question I wanted to ask was, how do you bootstrap the entire systems? You did talk about DNS, but maybe you can elaborate a bit more.
Yeah, for sure. When we talk about for how it all gets bootstrapped, you need the platform with the information about where the services are kind of needs to be there first. So in the case of a platform like Kubernetes or Nomad or ECS or one of these kind of container schedulers, the platform already knows which services are running. The process of bootstrapping for Consul is kind of more about starting Consul and then telling Consul, hey, here's what's running in the system. We already know what's running. Like a bridge system, basically, that's going to be watching an API, for instance, the Kubernetes API, watching for what's running there, and then telling Consul, hey, this is running there. And we talk about something like a platform like virtual machines, where there is no kind of overriding scheduler that knows everything. In that world, the services actually need to tell Consul, like, hey, I'm running. In that world, what we do is we have either via an API or via a config file, where when the service is running, it kind of tells Consul, hey, I'm running here. This is my IP address. This is my port. So that's kind of how we see the service discovery information get into Consul.
Okay. Can you also touch upon how do you find out if a resource is down on the health monitoring? How does that happen?
Again, it's kind of this the split between depending on which platform you're running on. So in platforms like, again, Kubernetes, Nomad, ECS, those platforms actually already have the information about the health of each service. And the reason they already have that information is because they need to make decisions about, oh, this application is down. I might need to reschedule it or restart it, or at least give a warning to the user. So these systems already have this information. So in this case, it's a matter of syncing that information into Consul and telling Consul, hey, Kubernetes says my web service is down. You should know that too, so you don't also route traffic there. Now, in addition to that, which is kind of configured on the platform side, and usually this is active health checking. So the platform person who's running the service will actually configure, like say, for instance, hey, call me on my /health endpoint every minute. And if I don't respond with a 200, treat me as unhealthy. The platform will then mark the service as unhealthy. We'll sync that information into Consul. We'll know not to route to that service, or at least perform whatever we want to do there. There is an additional type of health checking called passive health checking, where we actually notice on our calls between the different proxies that, hey, I noticed that the platform says the web service is healthy, but every single call that I'm making to this instance is returning a 503. And so we're actually going to be like, okay, well, I think the platform's wrong here. I actually think that that application is unhealthy. And we're internally going to mark that as unhealthy, and we're not going to route to it anymore. So there is a kind of almost two layers there of health checking. So that's like kind of the platform view of the world, where they already own that information and we just sync it to Consul. And then when we look at a platform that, for instance, virtual machines, where there is no overarching scheduler, in this platform, Consul will be the one that's doing the health checking. So you did allude to this earlier, where our architecture for virtual machines is we have a Consul client, which is just a process running on every virtual machine. And so in that case, it would be that Consul client's job to make calls to the application, however it was configured. Maybe it's a /health endpoint. So it would actually be making those calls to the application, and then it would be noticing that it's down. And then that's how Consul would know that the application is no longer healthy.
Okay. The next question I need to ask you will have to be on load balancing. There was an interesting discussion in episode 264. I just listened to it a few days back. And James said that I think the question that the host asked was, if load balancing was a part of service discovery, and he answered that if service discovery was done right, you wouldn't need load balancing. What are your thoughts on that?
It's interesting. I think
Putting you on the spot.
I think maybe I can get at what he meant by that, which is that if I say I have two instances of a database and one of them's under load, that when something's asking me, hey, what are the IP addresses of the database? perhaps my service discovery mechanism wouldn't return the IP address of the database that's overloaded. And instead, it would only return one IP address of the one that's fine. And so that health information in the load information is built into the service discovery mechanism. However, I think it's hard in service discovery, harder to do this kind of thing than in service mesh. It's just kind of like any other field in our technology area here, where sometimes you need that extra layer of programmability and an extra layer of control. When we end up putting all this stuff into the proxy, and the proxy is the one that decides where to route these requests, you now have just basically infinite control over where these requests route and what kind of load balancing you want to do. So for example, you might want to do load balancing based on, I already sent 100 requests over to this database instance. I'm going to start sending these requests over here. So that would kind of be like this proxy is keeping track of its own, where it's been sending requests. But you might also want to do some more complex load balancing around, I noticed that this instance of the database responds way faster than this instance. So I'm just going to send all my traffic to the one that's responding really, really quickly. This kind of locality aware load balancing, that is very, very hard to build into a service discovery mechanism, because how would the service discovery system know that that place was closer to that call would be faster for this specific instance, right? So you can see how when you get into it, there's a lot of complexity and extra kind of goodies you can get out of a service mesh, because you're at the proxy and you have full control, and you also have full observability into what's happening with my requests at this level.
You talked about observability, and I was going to ask about that later, but I think maybe it makes sense to ask now. I read about service level observability in the literature. What does this mean? Do you have a dashboard where I can see new services or how the communication requests are happening?
Right. Yeah, there's a lot of acronyms around there: service level observability, service level objectives. So when we talk about like observability as service level, really what we mean is there's metrics that tell us what's happening with this service. There'll be like application specific metrics. So you might want to have a counter around how many times a specific endpoint has been called, like /signup or something like that. Or you might want to have metrics around how long your database calls are taking. So something you might want to alert on there, right? When we look at kind of where does this tie into the service mesh, before the service mesh exists and you just had your application, your web application calling your database, you could already instrument that. So in your code, you could put a start timer, then you can make a call out to the database. And then when the response comes back, you look at the time and you do how long did that take? And then you call your metrics library and you emit some sort of metrics. And maybe that might fire off over to like StatsD or Graphite or something. So we already had this ability to instrument our applications. But what we found was, you now have to write this code, which is kind of annoying, because I want to just focus on my business logic. And also, I forgot to write this code. My name for this time to talk to the database was request_time, but the other services, they called it request-time. And so now when you're an operator and you want to like kind of look at, I wonder how long calls to the database are taking, you now have 100 different metrics names, and they're all using different technologies to emit these metrics, right? Or they haven't even instrumented it. Where the service mesh helps with this is, again, because everything's going through this proxy now, we can emit the same name for that metric across all our different proxies. We can program the proxies to emit the information in Prometheus data or Graphite data. So we have kind of this full control now where we can emit the same metrics. If the team hadn't accidentally instrumented their calls to the database, it's not a problem because all their calls go through our proxy. So we're definitely going to emit those metrics. So that's where we see the service mesh really, really helping with this, where you can kind of have metrics, observability into your service across all the different services across your app, across your infrastructure. We can talk about this later, but again, not only can you now get this information, but you can actually do something about it, right? If you notice the calls to your database are slow, you could maybe make a call. Okay, well, we're going to spin up a second instance of it. and we're going to start like routing 30% of the traffic to it or something like that. And you could control all this from like the operations center, basically.
Nice. Very cool. Maybe I can switch gears a little bit into what kind of support for infrastructure you provide. I'm thinking in terms of how do you integrate networking with CICD? Could you talk us through that? And maybe as a, the maintainer of Atlantis, do you use that a lot as well?
Yeah, they're connected in some ways and disconnected in other ways. So when we're talking about deploying the service mesh itself, that is more kind of a static thing that you'll deploy a specific version of Consul, and that will run for a decent amount of time in your infrastructure. Maybe you'll update a release every couple months to get the latest bug fixes or whatever. You could kind of pick your CICD pipeline of choice for that deployment. Probably it would be whatever you use for your other services. And Consul can run in Kubernetes, and it can also run on virtual machines. So that's kind of how you would do that. And then when we look at CICD for our like applications themselves, obviously you can just deploy those as you would before. And kind of the one difference with the service mesh is if you're running, for example, in Kubernetes, what we can do is we can intercept that request to, hey, deploy my web service. And we can automatically add in this proxy to that. And so when that web service comes up, it's now got that proxy already running. And that proxy is already connected to the Consul control plane, and boom! Now that web service is in the service mesh, and we can start to program its traffic and do certain things with its traffic. But it can also come into play too, where when we are deploying a new version of an application through our CI/CD pipeline, maybe what we want to do is we want to, say we have 100 instances of it, we want to deploy 10 using the new version, and do what's called a canary deployment, where we route like a very small amount of our traffic to those 10 new instances and closely monitor the metrics. This is where we can see the power of being able to program your network and do whatever you want with the routing. It's going to be really easy to route only 10% of or only a small amount of traffic to those 10 instances when we have a service mesh and all of our calls are leaving proxies across our infrastructure. So we can just program those proxies saying, hey, if you're talking to the web service, I want to send 1% of your requests over to these canary deployments.
So when you talk about programming your network, what's the support? So you're saying that you can define a new configuration, I guess, declaratively, right?
Right.
How do you do that? I guess I'll let you answer that maybe.
Right. Yeah, what we do is we have this basically configuration. In Kubernetes, it's YAML, of course. And basically, we have lots of different service meshes have kind of their different ways to configure this. In Consul, we have a couple of different like types of configuration that let you, for instance, we have this one called a service splitter, where you can say identify, for example, that canary deployment, and you can say, hey, I want to send 10% of my traffic there. So what you would do is you would use a custom resource in Kubernetes, basically that has that information that says, hey, requests going to the web service, I want you to route 10% of them over to the V2 of it. When we look at kind of if you're running on VMs, it's the same kind of thing, but instead of having a Kubernetes YAML, we can do it via like an API call to Consul with like either JSON or HCL, but it's basically the same schema. And so, yeah, it's all controlled via a kind of API, or in Kubernetes, it would be like a YAML resource.
Okay, perfect. I was going to ask you about A/B testing support. I think you've kind of alluded to it now. So this is the service splitter, right?
Right.
Which you just talked about. Can you explain that a little bit? Is that like something on the configuration that you set up on your YAML file?
Yeah, for sure. So yeah, it's exactly that. A/B testing would be, it's an interesting concept in terms of service mesh, because typically when I at least think of A/B testing, I think of a consumer, like a user using my website. And for instance, I serve the button in one case is blue and the button in one case is red. And then I have metrics around which one gets clicked more often, kind of thing, right? Within like the web service calling the database service, there's probably less use of the concept of an A/B test, but you definitely have this concept of needing to split traffic, maybe a blue-green deployment or a canary deployment. So yeah, what we would do is you have this configuration entry where it would identify that I want to send a certain amount of traffic to the service, 50%, for example. And then I think what you could probably do too is you could identify like separate metrics for that request that went over there. And you could kind of like see that on your graphs, that the traffic that went to the blue button, there was more requests over there, something like that. So you could kind of configure the metrics that got outputted there.
Okay, perfect. Sounds good. I got my answers, so that was great. I would like to now switch gears. So we talked about service discovery. We've done a little bit about health monitoring, infrastructure support, and my personal favorite, security. So you talked a little bit about it in the beginning, but can you explain how you handle security in terms of authentication and authorization?
For sure. Yeah. And I'll kind of preface this discussion with what we've seen. And I'm sure if anyone's been a security engineer at a company where they move to a platform like Kubernetes, for example, what we've typically seen for security, which is basically you have a firewall, you have security groups between your apps, and you have kind of this control of like, okay, this IP address 10.10.10 can talk to, IP address 10.10.05 or whatever. And I have this rule and it's listed down. And if I ever want to change it, I put a ticket into operations, I change it, right? Very, very static based security. We're moving into it. We're already there really into this new world where it's too dynamic for that to happen. In a scheduler, you're going to have these pods with IP addresses that change all the time. They come up and down. You can't have these static IP address lists, right? What we need to do is focus on the idea of like service identity. So it's not about this IP address port pair that identifies a service, but instead that service needs to have some other sort of identity that we can use to authenticate it. So when the web service calls the database service, how do we know that it's the web service? We can't look at the source IP anymore because that's changing so fast. So, and in addition, in places like Kubernetes, by default, unless you're running with like network policy or whatever, the network's totally flat. So there is no firewall rules between what can talk to what. By default, it's completely open. Anything can talk to anything else, which developers love and security folks are probably pretty scared about. So what we talk about in that case is this idea of a zero trust network, where you can't base your trust on who can talk to who based on IP addresses. So what do we use? Most service meshes, what they will do is they'll actually use MTLS, mutual TLS. And what that is when the web service talks to the database service, it speaks over SSL, so HTTPS. Not only when I talk to, so for instance, when I talk to google.com, my browser will make sure that the certificate served by that is actually served and owned by google.com. So I can't get what's called a man in the middle. What mutual TLS is not only do I verify that google.com is google.com, but Google will verify that this is Luke that's making this call to me. So when we go to our web and database example, the web service gets a certificate that actually identifies it as web. It's cryptographically verifiable. It's been signed by a trusted authority that says, yeah, this is the web service. And so when that request goes over to the database service, not only can the web service verify, okay, I am talking to the database, I'm not sending my database password somewhere incorrectly, but the database service can look at the client certificate, which is coming from the web because that's a client. It can see that it's been cryptographically, or it's been signed by the trusted authority, and that it actually is the web service. So that's kind of the first layer there is this idea of mutual TLS. So we both know who each other is, and we both are trusting that each other is who we say we are. And then you have kind of in Consul, we call this intentions. I'm sure there's many different names of it for the different service meshes, but it's basically just an access control list, which says, okay, I know this is the web service talking to me. Are they allowed to talk to me? And so we'll look up in our list and it says, okay, yes, web is allowed to talk to me. We have kind of, you can go even deeper with Consul. We have this concept of layer 7, which is basically like you could look at the HTTP path that it's using. So, okay, the web service is allowed to call the payment service at /billing with like a GET request, but it can't do like a post request to like /admin or something like that. So you could kind of get even deeper into these authorization and these security layers. But the overarching concepts are this idea of MTLS, where all communication is encrypted and over SSL. And then each side of the party who's party to this communication can verify that they're talking who they expect to be talking to.
Okay. Actually, I was going to ask you about zero trust because we did an episode 385 on zero trust. And, one line, I think you've explained it beautifully, but one line that really struck with me during that episode, the host was actually quoting a Google engineer who said, do not trust your network. It is
Right.
probably already owned.
Oh,
So
wow.
it's deep, but that kind of perfectly, I think you've answered it because if I were to summarize what you said, you really don't trust any of the new nodes that are coming up unless you basically don't trust anyone, and then it all depends on your certificates and this MTLS that you talked about. And
Yeah.
also you said you have further granularity, right,
Yeah. I think
in
the
terms of permissions.
zero trust networking, it sounds kind of a bit confusing maybe. And really what we just mean is you can't use firewall rules anymore based on IP address.
Right.
That's
Right.
really what it is. It's like you're running all your networks on like the public network on EC2 public or whatever it used to be called. Anybody can talk to you, and you can't just set up firewall rules. Obviously, you should have defense in depth, and you should actually have firewall rules. But that's generally the concept there.
Right. I guess you can't just really trust that a perimeter defense is good
Right.
enough. It's no
Yeah.
longer safe.
Exactly. Yeah.
Also, get back into what you talked about, this multi-platform service mesh. So I could have, like, for example, in my company, we probably have a Kubernetes cluster running on Azure, and we do have, some legacy VM running some important jobs.
Right.
There could be, there are some VMs on our data center, but we also have some VMs on another cloud provider, like say Google.
Hmm.
So how does Consul handle the situation? Yes.
Yeah. This is something that is extremely common. It's very, very difficult to handle, at least in the world before service mesh. We try to make it a little bit easier with the service mesh. So what we have the concept of with Consul is this idea of a different data centers. However, you can also think about it as different clusters. They're really kind of interchangeable there. When you have your Azure Kubernetes cluster running and you have your virtual machines running, ideally, what you want is, first of all, you want that zero trust networking. So you want when the legacy, say the web service that's running over in your Azure cluster, your AKS cluster, wants to talk to the database that's running on-prem. So that's maybe what you call it, legacy.
Mhm.
You want that request to be encrypted, obviously, as it goes over there. So that's the first thing. And the second thing you want is you actually want it's actually not that easy, probably, to route over between the two of them. Because often when we're talking about multiple different data centers, clusters, the networking spaces aren't overlapping. And so you can't just take the pod IP and talk to it from your on-prem data center. That pod IP doesn't exist. It doesn't know where to route that, right? When we're talking about multiple clusters, we need to add in this concept of gateways. So
Mm.
gateways are kind of sitting on the edge, and they have an IP address that is routable from either cluster. So maybe it's a public IP, or maybe it's still private, but it's not a pod IP. It's something that actually exists that you can resolve. So that's kind of the first key piece there is you need this thing that sits on the edge that is routable. Obviously, you need to get somewhere it needs to be routable. We also have a concept of VPNs where everything's within the VPN, so everything is routable. So in this case, you probably wouldn't need this gateway. But then when you're talking about a VPN, we're kind of going back to what we're talking about with this perimeter security, right?
Mm.
So we can't just like blindly trust our VPN. So that's the first thing we need when we're talking about multi-data center. The second thing we need to do is we need to be able to communicate what's running where and whether it's healthy or not, right? That seems pretty easy on the face of it. Just make an API call and find out. But maybe one of the reasons we're running multiple data centers is for failover and for reliability. So what happens when this data center goes down? This mechanism of understanding what's running in each data center needs to be really resilient to failure. Those are kind of the main concepts at play here, or is like the routability, usually through gateways. There's the security aspect of it. So you say that you're the database. How can I trust that you actually are the database? And then there's kind of the reliability and failover aspects of it. So Concretely, what that means in Consul is we would have you set up a data center, Consul data center, which is basically just a set of Consul like processes running in your AKS application. You install it through the Helm chart. And then you'd also set up a set of Consul servers in your on-prem cluster there, your legacy cluster. And those would be connected and they would trust each other through a set of shared certificates. And then depending on how your networking set up, we would have some gateways on the edge so that we could actually like call between the two data centers. And then when the web service running in Azure wants to talk to the database, it just talks to its local proxy. And that proxy handles it from there. Under the hood, what it's doing is it's going to be using a certificate. It's going to be recognizing that the database isn't in Azure. It's actually over in this other cluster, this legacy cluster. It's going to be sending it over to the gateway for that legacy cluster. The gateway is then going to be looking at the request. It's going to see that it's signed by a trusted certificate. It's going to let that request through. And then it's going to be routed directly to the database's proxy. And then the proxy is going to look at that request. It's going to look at the certificate. It's going to say, okay, it's from the web service and web is allowed to talk to me. And it's going to route over to the database. So under the hood, it's actually quite complicated. But from the perspective of each cluster, it's kind of easy. You just talk to your proxy and everything gets handled from there.
Okay. Sounds probably easier also because you're directly just talking to your local proxy. So
yeah, definitely. Each application doesn't really need to know where other applications are. So if say you were to migrate that database later somewhere else, you could just do that and make sure you don't have to really make any changes to the web service. You don't have to redeploy it or anything.
Okay. I wanted to also find out from you if you could again elaborate a little bit about this failure in retries, because I think all this distributed communication needs this infrastructure support for this scenario, right? Can you just go over that again?
Yeah, for sure. So as we saw the move from monolith to microservices, what you used to have was your function call. Now it was actually a network call, and occasionally that would fail. So we started, at least what I did, what we used to do was we would build some for loops into our code where if it fails, just retry it again. Basically, you end up writing a bunch of logic in your application that handles kind of these failures. And then, somebody would get fancy and they'd implement like an exponential backoff or something like that, right? But each application developer needed to do this themselves in every single application for every single network call. At least what we found was someone would have something, right, where they're like, well, we really need this call to succeed, so we're going to retry it 20 times. What would happen is that service they're calling, maybe it gets a bit slow. And so maybe that first call doesn't succeed. And suddenly it's getting hammered with 20 times the traffic because this application in its wisdom is just retrying the call a ton of times. And now the application is actually hard down because it's getting 20 times as much traffic as it used to. So that's kind of setting the stage for where we started to go as an industry. And there were libraries out there that would kind of be smarter. But that was kind of the problems we had to solve. And so what we get with the service mesh now is don't write a for loop in your application that tries this network call 20 times. Instead, try it once, send it out to the proxy. And now inside the proxy, we can control that 20 loop. Maybe we do want it to loop 20 times, but maybe the service is down and we actually only want it to loop once or to wait 5 seconds before it tries again. Now all this logic kind of gets put into the proxy, and then we can configure it similar to what we were talking about before with the service split. We would have a configuration file or a YAML file, which basically configures the behavior for failover. And I can go quickly over kind of the different things you could do. So one thing you could do is you could retry. You could retry with an exponential backoff. You could do a circuit breaker pattern where you recognize that service is hard down. And so instead of making the application who's making that call wait for 1 second until the call times out, you just fail it right away. So immediately that call fails. The application still needs to deal with the fact that call failed, but it doesn't have to wait 1 second, which might mean you get an error page really quickly from a user instead of having to wait for your call to time out. And another thing we can do, when we did just talk about multi-cluster, but we could maybe look at failing that request over to one of this other clusters that we think is still up and running. So ideally, we only talk to our local cluster because it's faster. But in times of trouble, we might fail over to this other cluster over here. And the call takes a bit longer, but at least it succeeds. That's kind of what we look at when we look at how do we handle failure. And the only other thing I'll add is that when we go back to observability, we now have a common set of metrics with which to diagnose that this is failing. So these very complicated architectures will have every single proxy is emitting a metric that's saying the database is down. That's pretty darn good information that the database is down.
Yeah, it's just got me thinking a lot of stuff.
It's your database
down. Yeah, exactly. Yeah, but coming back to the episode, yeah, so this is great. I mean, if I were to just recap what we've just spoken about, you led us through service discovery, health monitoring, and right now we spoke about this multi-cloud support and also this failure and retry scenarios. Can we step back and also talk a little bit, which I should have asked you in the beginning, but I got so into this. But could you tell us about how this control plane and the data plane work, with Consul and Envoy?
For sure, yeah. So at a high level, when we think about data plane, what we mean is each application calling the other applications through the proxies. So this is the data. So if you try to, it's kind of hard on a podcast, but visualize in your head, you have like on the bottom of the diagram, we have like application web talking to application database, and they're both talking through a proxy. That's the data plane. And then above all that sits the control plane. So this is a Consul or Istio, and this is talking to the proxies. So it doesn't talk to the application, it configures the proxies. Now, obviously, there's a lot less communication going on here, but the control plane needs to tell the proxy, hey, split half of your traffic over here, or hey, I want you to retry every 1 second or something for this. So that's what we call the control plane. So the data plane is the applications talking to each other through the proxies, and the control plane is what's controlling all the proxies.
Perfect. The next logical thing which I've not covered right now is also about performance, and how does that work with having this extra layer with Consul? Like, do you do something similar? Like, do you do something for clients who demand that you do something special for performance critical applications?
Yeah, that's a great question. And I think that is something that's often missed when we talk about kind of the wonders of service mesh. Is there can be a performance implications, because you're taking this request that used to leave your application and go over to this other one. And now that's hitting some other process, which now has its own memory, and it needs to process these, and it needs CPU cycles to process it. And maybe it's doing some complicated things. Maybe it's doing SSL, right? So it's definitely not a free lunch. If you're talking about extremely low latency applications where microseconds matter, then adding a proxy in front of everything is definitely going to make an impact to your application. And if there's other developments around like eBPF, this idea where why don't we do a service mesh, but we do it inside the Linux kernel itself, so it's a lot faster, so we don't have to go kind of swap back into user space. So there are developments with these kind of extremely low latency requirements. But I think what's worth mentioning is that most applications don't notice microseconds. They're going to notice a couple milliseconds, but a couple microseconds are not going to make a big difference. And instead, what makes a big difference is being able to build applications faster, deploy them, migrate them, control them, and handle failure faster. So for many of kind of the microservices use cases, the extra performance hit you get from a service mesh is well worth all the control you're getting. And in some cases, it's actually faster, because in the case of load balancing, where we're able to intelligently route to the applications that's closest to us, whereas before we were kind of just blindly firing off to all the different instances available, you could actually see your requests actually complete faster because you're talking to the one that's closest to you. There is a performance hit, and it's not negligible, but in general, what we find is that it doesn't make a huge difference to these applications. We're talking about maybe an extra couple milliseconds. The control it gives you is well worth it.
Now that we've sort of covered a range of things that the Consul does, how would you differentiate it against the other service meshes out there like Istio or Linkerd?
Consul, what we're very focused on is this idea of multiple platforms. So Consul started out of virtual machines. A lot of the service meshes kind of were Kubernetes first and Kubernetes only. Some of them still are.
Mm-hmm.
So that's a big thing for us is this idea of how can we make a kind of the UX, the user experience of the service mesh, and how to deploy it the same across multiple platforms, be it Kubernetes or ECS or VMs. So I'd say that's kind of what we focus on as our differentiator. And then also we do focus too on like tie-ins to other Hashicorp products. So for instance, like if you're using Vault, then you can use like Vault to control some of the security of the Consul service mesh. So that's kind of what we think of as kind of our special sauce there is multi-platform. And then we also have a program called the Hashicorp Cloud Platform, where you can actually get a hosted version of Consul, so you don't have to manage kind of all the operational complexities of running your own service mesh. So that's another really, really big initiative for us, where we have our own team of SREs that kind of manage this for you. And again, because we're not owned by a specific cloud provider, we can provide this across different clouds, and we can provide multi-cloud support. So that's another thing that I think is worth calling out, is kind of like we're always about multi-cloud, multi-platform, and we don't really have like specific tie into a specific cloud. So I think that's kind of like the differentiators for us there. But they're all great. I think all the service meshes are good, and depending on your use case and what you're doing, I think all the folks working in the service mesh industry are doing really, really cool stuff.
Okay. So can you suggest some good resources for our listeners to look up on Consul?
Absolutely. This podcast would be great, but you're already listening to it.
I like that.
We have, I think the best place for folks to start is we have a really great website called learn.hashicorp.com. And it's all about kind of these hands-on tutorials for kind of just jumping into the tool. And at least personally, that's how I like to learn. Of course, you can read all the documentation too, but I like to just play around with things. So I think that's probably where I would tell folks to start is go to learn.hashicorp.com, look at the Consul, different tutorials we have there, and just start walking through it, get Consul installed and start messing around with it. And I think that's a really great place to start.
Okay, I'll make sure that I put that in our show notes.
Okay.
Where can people reach you if they wanted to like touch base, like somewhere on Twitter?
Yeah, the best place to reach me is on Twitter. My username is LKYSOW, Kysow. So yeah, hit me up on Twitter, and my DMs are open, and I'm happy to discuss anything.
Thank you so much for this interesting conversation. I feel very enlightened, like Buddha. So yeah.
Thank you so much for having me. Good luck on your database woes at work.
Thank you. This is Priyanka Raghavan for Software Engineering Radio, and I hope you like the show.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.